Go ahead. So there you go.
Yay!
So good evening po ulit, Sir J and Josh. We'll be having the
Kanina
last,
po.
hopefully. This is the last session for chemical bonding, and we'll proceed immediately with IMF. So for this time po, or for this session, Josh will be answering the last part. So this is an open-ended questions ito. So we'll be having the first three questions first. Sige po. Sige, go ahead, Josh. You can share your whiteboard and then
Opo.
let's see kung ano yung maano mo. And by the way, Josh, meron na akong ganito. Ay, nakikita mo ba?
Ay, yung ano pa yung mga panggawa po ng ano, gawa po ng
Yeah,
chemical, ano.
saktong-sakto kasi eh. Chemical structures. Saktong-sakto kasi yung topic natin. So sabi ko, mukhang saktong-sakto
Yung mga,
naman siya.
yung mga ganun.
Oo,
May ano daw, may bibili po sana, may ano yun na, may binili. Ang
hindi,
ganda.
nakalimutan ko pong bumili. Buti pala
Oo.
napansin,
Di, kasi ano talaga yun,
kasama
sir,
dapat sa box.
na naisip ko na kaagad na, ay, pwede ko tong iregalo kay Diyos. So, sana meron pa siya. Ay, wala pa siya nito. So, ayan.
Yay! Neopentin. Or not, I don't know.
No, no, no. This is ano nga ito? Methyl allyl chloride.
May sila.
So don't worry, you can draw methyl allyl chloride once we're in organic chemistry na. So far, feeling ko hindi mo pa may imagine kung ano yung methyl allyl chloride. But you'll
Opo.
have an idea. Actually, methyl eh. So methyl and then allyl. Anyway, sige, start ka muna dyan bago tayo mag drawing.
Uh, Actually, I don't know what this. With each atom receives an octet of electron, I don't really understand because every time you put a structure, all the time it will always have an octet. Alas na.
Okay, let's see. You can defend that. You can defend your answer later. You just write your answers first. Sige, go ahead. By the way, Josh, for the 1B, it's referring for the most stable Lewis structure of your O2. Go ahead, continue lang. Pink Panther yan, di ba? Yung ano, ano ba? Pink Panther. Yung hum.
Narinig ko. Ano?
Yeah, I can hear it.
Ay, something's not right. Partial equivalent. Ano ba? What's this?
Okay na ba? You're done?
Di ba ba?
Okay. Okay, go ahead.
Something is telling me this is not correct. Tama.
Oh, you try to analyze. You try to analyze. So, azide is N3 negative. Try to count first the number of valence electrons for azide.
I'm also trying to check this B point. I don't know if it's the oxygen looks so that it can bond like fluorine.
Like O single bond O.
Oh, but why? I'm wondering why is it like it's still technically like this, even though it's not supposed to be like that. Hmm, something's not right.
We'll defend your answers or you defend your answers later. But for azide, sige, to guide you sa azide, just make sure that everything will be what do you call this? Be bound by the laws of chemical bondings. Um, yeah. Sige, or the most, parang most logical naman siya. The most logical
Most logical.
formation
Ito
for
po,
bonds.
most logical, but not really. Does not
Sige.
exist in real life.
We'll see, we'll see.
Kung nag-exist mo yan, baka ma-atake na po ako. Uh-huh. And yes. And...
For number 2, you draw all other
Ah! Wait
possible
lang po.
resonance structures. Go ahead.
Ah, okay. Yes. Oh, you are the reason. You're the reason why I was about to make a grave mistake. Huh? I'm angry. I didn't see that sooner. I knew immediately something was sussy. And indeed something was so sussy. I cannot control it.
Okay, go ahead. Oh, I'll guide you how you count the valence electrons first. Para at least you'll be guided on how many electrons you'll see there. Calculate mo yung valence electron.
Ano po? Calculate valence electron. How do I calculate valence electron?
I don't know.
15.
So,
Maybe.
the group number, then you'll add, kasi dahil negative siya, so how many electrons will be added? Add or subtract? So, di ba, you have an overall charge for AZ. So,
There's
AZ
a
is
negative. So, only
negative
one
1.
has to be
Okay,
added.
so what's the total? What's the total valence electrons now?
16.
Okay, so good. So you need to see at least 16 valence electrons there. So, and then try to review your structures. Do you see 16 valence electrons there? That will guide you. Yun yung clue mo, ha? So, ayan. Go ahead. Continue.
Uh, something is wrong. Something is very wrong. 1, 2. Yes, this is not obeying the laws of chemistry. I do not know why it adds negations. Right. Looks like a 6.
Okay, go ahead.
Mm. Mm. Go. Alright. There's not enough
Okay,
space.
sige, you're doing good.
There's not enough space po. So, goodbye.
Oh,
There's not enough space.
Sige.
I have to make it bigger. Like, real bigger. Ay, brain glitch. That looks like a whistle, bro.
that's good, Josh. That's good,
Look at the time. I can't do anything. There, finally.
Iniisip mo yung external muscles na nagpo-focus. Mali. It's your brain.
See? That. Hey, look, soy sauce doesn't absorb well. It's too salty. Mm-hmm. Mm-hmm. Mm-hmm.
Or you calculate the bond order as well. You're done, Josh?
Sila ba?
Okay, sige. So, band order lang naman yung need mo nang i-calculate. Hi, I think you're done.
Sila pa pala.
Mm-hmm. Sige, go back to your first page. Okay, so, okay, may skip ka pala. Sige, you try to finish this number 2 na.
I mean, it's already
Just,
finished. But technically, not really.
Sige.
I have 1 million questions.
Okay, sige. We'll start now, So, let's start answering this one. Okay, so, number 1. What is, I think the answer here, or the question here, construct the most stable Lewis structure for O2 in which each atom achieves an octet of electrons. So, of course,
Okay,
we know already that, okay, tama ito.
abo.
Let's say 2 points ito. Can you see my annotation?
Yung mga blue po or hindi po siya technically kasama sa solution. Most of the time, they are contradictions or side notes lang po.
Okay. Yes, okay. Sige, sige. So, this is 2 points. So, it is necessary to promote stability, blah, blah, blah. So, why is necessary to form a double bond in Lewis structure?
Oh,
So,
unpaired electrons, no
okay,
unpaired
correct.
electrons,
So,
etc. Actually, it has unpaired electrons. It's just not visible much sa Lewis structure. And that's why it's
that,
paramagnetic point. It has unpaired electrons. Anyway,
mm.
technically not. Nasa ano po, nasa Lewis structure. Anyway.
So, actually, you have many answers for why do you need to have um, double bond. So, number 1 is to achieve octet. Okay, syempre kapag single, um, pag single bond, actually you'll achieve octet pero unstable. Okay, to achieve an octet electrons na stable. So, or to achieve stable octet electrons. Or another thing is you can have a more stable structure or uh, to satisfy the covalency number of oxygen, which is what is the covalency number for oxygen, Josh?
Uh, 6 po siya, so dapat 2. 2 bonds dapat po.
Correct. So 2 bonds. So it's also your it can be an answer as well. Okay. So with this, another thing is very good. So nakuha mo talaga yung main reason kung bakit kayo nag-a-add ng double bond so that you can have zero formal charges on both oxygen. Okay? So kasi dito kapag um uy, eto ano to? For your O single bond O.
Well, technically still true because it is true.
Mhm.
I don't get how could it not be wrong because it's true naman po. 6 minus 1 minus 5 is indeed 0. It's just these
So,
unpaired electrons that are concerning.
mhm. Yeah. Okay. So, but this one, okay. So, if you will have this one, you'll have a what? A formation ng,
For me, ano po?
kunwari, if you have O single bond O lang,
O single bond O.
Ayan, ito. This one. Diba this is O single bond O, right?
Abo.
Mhm. So, if you will have that structure, what is wrong with this? Correct to, too many lone pairs a man, or you can also what? You'll form what?
You
Oh,
will
may
form
unpaired ka. So, this is what? This is a
radicals. It's a radical,
very
technically.
good. Oh, correct. This is a radical. Because radical is any molecule or any atom that contains an unpaired electron.
Oxygen,
Okay, so may
oxygen,
radical ka.
oxygen laughing in distance po.
Yeah.
And
Mm-mm. So,
a radical something is a molecule that contains an unpaired electron.
okay,
Bro.
tignan mo to. Hmm, can you draw H2O2? Can you try? Dito na lang.
H2O2, you know why? Ganun po. That's the reason. Because H2O2 is literally, wait, I'll just try
Go
this.
ahead. Okay, go ahead. Mm-hmm.
This is a,
Uh,
ah, bro,
Bakit na po?
why? I was just trying to erase the
Sphere
oxygen.
model na pala ginagamit mo. The sphere model.
Yung ano po, space filling.
Correct? Sige, go ahead. Basically, OH and OH. May wrong ka dito. Dapat ganito. Ito, and then ganito. Di ba? Hmm.
Why? Di ba sa'yo
Sige.
is negative?
Hmm.
Anyway.
It's not OH negative because you have a radical there. So usually hydrogen peroxide, Josh, this I'll teach you this one. I'll share you this one. Hydrogen peroxide is actually a very active compound because this can undergo easily decomposition upon exposure sa air. So definitely you'll what? You'll break your bond homogeneously. So homogeneous um, or homolytic bond breaking. So when you say homolytic bond breaking, how many electrons for each bond, Josh?
Two.
Okay, correct. So when you say homolytic bond breaking, you'll separate the number of electrons equally. So what will be formed here upon the composition of H2O2?
Yung ito nga po, OH radical plus OH radical.
Very good. So
And
you'll
then,
now
those are
form.
totally not stable. So, the H would rather go with the other OH, so it will form H2O.
Mhm. Yeah, one of this can react with and actually any of those can react with your other molecules to form a stable bond. By the way, Josh, if you will notice, kamukha nitong pinaghiwalay mong OH, ito oh, yung single bond O mo because you'll form radical. So just imagine yung isang bond lang dito ay naka-bond kay hydrogen. Okay? So, yeah. So the formation of single bond O oxygen single bond O will lead to the formation of a radical. So it's not ideal to have this one. So therefore, you introduce a double bond here. So a double bond, yeah, correct, may mas compact structure and mas stable. So palitan mo lang tong compact with stable kasi mas ano yun, mas correct na term yun. More stable structure, formal charge will be zero. So in reality, O single bond O exists, surprisingly stable in other planets with different atmospheric composition. Yeah, actually pwede ito, pero yun nga lang, this is not allowed under our current conditions. Okay? So, yeah, this is a good ano ha,
So, yung
information. Can you give me if this one is stable at other planets, can you give me a specific location sa ano natin? Solar system ba natin ito or sa stars or what?
Solar system po.
The OO. Saan?
Solar system po.
In what specific place in our solar system?
Titan po.
Sa Titan, nag-exist ang O single bond O. So,
Opo.
let me check
Very sparse.
This,
Pero
this is
ano lang
really
po,
interesting.
that's sa
Yung
mga, yung mga,
OO.
pwede rin, it actually also exists syempre po sa space kasi very weird yung space chemistry. Pero po,
Mhm.
yung sa Titan, there's a very small percentage that you will find single bond oxygen po kasi hindi rin moments po yung mga stable po na mga atoms po dito, hindi naman po stable doon
Mhm.
kasi yung pressure difference, tsaka yung temperature difference din
Mhm.
po. So, the O radicals po will coalesce. So
Malay mo yung ano din,
they would rather
you
form
have
like
ano, O single bond O here as well because you don't know every composition din naman or every condition sa Earth, di ba? Ozone nga nag-exist sa stratosphere eh.
ano ba?
Might as
Meron pa
well
sa
this O single bond O. I
hala.
don't know I don't know. Kasi I don't have any journals na nababasa so far based from what I'm seeing. I'm not seeing O single bond O present in Titan. But actually, um, yeah, most probably, O single bond O can exist, I believe sa ano ito, atmosphere. Pwede ito mag-exist.
Me existing. Well,
Hmm.
ano po, teacher po. Hmm? Prove
Hmm?
it. Me po, literally making a rocket and traveling to Titan.
Pero kasi may O ano ka eh, O band, pero bihira yon yung O single band O. Okay? So, quite very unstable kasi
May
yung O
ano po,
single
may
band O
question
due to
po.
the formation of your R radical. Go ahead.
Opo, so di ba po sa H2O, ganun po yan.
Mhm.
So, for H2O2, you replace the H by OH.
H2O2, you replace H by OH. Okay?
Ako diba? So now, like hydrocarbons, you might find me
Mhm.
crazy po, but I have
Sige.
decided to make the most first possible thing. Is this possible?
OO, then HH? Tama ba
H2,
ako?
H2O3. Abo.
Hmm. Oh, this is an interesting question. Like this.
So if it's possible
Theoretically,
po,
this is ano.
Opo, if
Yeah,
it
this is actually,
theoretically it is possible, then is it
yun nga lang
possible?
unstable ito eh.
Opo, is it possible to synthesize as any possible other than H2O2 with this formula H2ON?
No. Unstable ang mga OO bonds eh. Because OO bonds cannot do this catenation thing na ginagawa ni carbon. Okay? So,
Why?
remember Josh ha? Sige, gagawa natin. This is actually O3 pa lang, itong H2O3 mo. This is quite unstable na eh. What is the stability of your oxygen? Electronegativity.
Electronegativity po?
Mhm.
High.
Okay,
So,
so this will be partially what?
partially negative.
Of course, hydrogen will be partially positive. How about this one? Partially negative din. And tignan mo ha, partially negative din to. What will happen to your bonds?
Looks
To,
as
negative ito.
two
Negative
negative
to,
bonds,
negative
then
din to.
negative, negative. And then there's a positive.
Again?
Basically, it's like, di ba po partial dipole pero it's a tripole?
Mhm. Mhm. That will
Wait,
make your
tripoles
bond
exist?
very unstable.
I know
That's
po,
the reason why,
it proves tripoles exist.
yeah, nag-exist naman talaga sila. Nag-exist sila. But the problem here is your charges here are tabi-tabing negative, oh. Negative, negative, negative. So, that's the main reason why your O bond is also unstable. O single bond O. Kasi you have both partial negative and then partial negative here. Both of them wants your electron. So this bond is actually very unstable. So parang mas gusto niya na lang mag-break apart kaysa mag-come together. Okay? That is the reason why you don't form a non-polar. Kung alam mo kung nagkataon lang to Josh, if oxygen will have this um, non-polar bond together, kasi nga, parehas naman kasi silang partially negative, they can actually have a quite a stable na formula. But due to this can easily break apart. Okay, so madali mag-break apart yan.
Sinasabi na po na hindi pwede may singa. Pero nakita ko po, na-research ko po, pag if you freeze oxygen,
Mm-hmm.
you can form this very cursed thing. I don't know what to call this, like a square oxygen.
Yeah,
So it is possible to form this at very low temperatures. And even form O8, which is basically four squares. Actually, it does not look like this. It's like a puckered square. Like,
yeah. No, wait, for 08, it's like this. Parang ganito siya. Oops. Ayan. Something like that. Wait.
opo,
Naka-reverse siya. Wait, let me
opo.
erase this one. Parang both confirmation yan eh. Twisted like this.
Opo. Parang nga po siyang,
Ayan, parang ganyan. Yan. Something like that.
opo. Tapos yung may ganyan.
Yep, correct. Ito
But
yan
it's
eh.
like,
May O ka dito, may O ka, may
pero
O
parang
ka.
ganun lang.
But this is quite in under ordinary conditions, Josh. This is not really stable. So they will just break apart because your oxygen want to form O2 eh.
As cursed as it could possibly be, pentaoxylene also exists. So, if 5 oxygens can chain up, and just even 4, the fact that 4 can
Your
even
problems there will be the stability of your bonds.
is it even possible to synthesize this po yung H2O3? Kasi if it's possible to synthesize O4 and even O5 and make it last for more than 1 millisecond, is it possible to make this molecule survive longer
This
than
is
that?
yeah. This is possible. Theoretically, this is possible. But the problem here, how long will it survive? Baka yung half-life mo nito, milliseconds lang. Wala na siya. Okay, this is possible. Okay? But in ordinary conditions, that definitely this will be unstable. So of course we know this is really unstable because you have two adjacent oxygen molecules there. So definitely your two oxygen molecules will try to parang pull apart your bond. So it's better for your oxygen to have their own electrons. Parang ganun yung gusto nila. Parang ganito yan eh. Dalawang sugapang atom sa electrons, pinagtabi mo, therefore, they'll try to push together away themselves or yung electrons nyo so that they will break apart. So, pero this is a good, that is a good observation, Josh. If you will notice, at very low temperatures, it's like parang everything is possible, right? Kasi,
Very
yung mga molecules mo,
chemistry na nga po ngayon eh. Yung very, very cold
yeah,
chemistry.
cryochem. Kasi kakaiba na talaga siya eh. So, at very low temperatures kasi, your molecules behave differently because they have low kinetic energy. So, if they have low kinetic energy, definitely, the things that we know in basic chemistry will change as well. Kasi, yung mismong mga things na alam natin because of their, kunwari, normal condition kasi, so, they have this high kinetic energy compared right?
Nawala po, nawala po.
Are
Nawala
you
po.
getting me, Josh?
Nawala po for like
Ay,
1
sorry.
second or something.
Hello.
Apo, meron na po.
Hello. Ayan. Naririnig mo na ako? Okay.
Apo.
So, parang at low temperature, like what I mentioned nga, parang tame yung mga atoms mo, di ba? At low temp. You can easily manipulate them.
Ganun po.
Yes, correct. Slow mo sila eh. So, parang we can easily, how do you call this? You can easily trap them and then make them react together to form yung mga unknowingly quite impossible compounds that we know from chemistry. So, ito, theoretically theoretically speaking, you can form this. Okay, if you want yung ano mo, yung proposal mo, H2ON, yeah. If you can polymerize oxygen ng tuloy-tuloy.
I can
Okay?
finally, I can
So
finally make
theoretically speaking,
yung ano po, yung Soviet miss na ano po, yung polywater. I can
what?
finally, I can finally create polywater.
Oh. Pero ano to ha, ang nakikita kong application nito, siguro ano, mga
Oxidation.
catalyst formation, radically induced reactions. You can use this one as an initiator. Okay? So,
Opo.
paano ha? 'Di ba kapag at cold, very cold temperature, this one can exist, right?
Opo.
Tama?
Opo.
Pero if you expose that at ordinary conditions, what will happen to your bonds?
Break.
Automatic they will form. Magbe-break yan, apart yan kagad. So,
May
ano
break po.
mabubuo mo?
Then that's exothermic.
Mhm.
It should
And,
be highly
ano mangyayari
exothermic.
sa mga atoms themselves?
They will just
Mhm.
break apart.
Sige,
They will
dun
become
sa mga ano.
normal radicals po. They'll just become normal radicals. Those radicals could probably sort of
Yes,
get to
correct.
work sa H2O2.
Ayun.
That's it. There's sa H2O2.
Correct, exactly. Another ano siya, yeah, correct. Another application, ang application niyan, Josh, is siya yung initiator ng mga radical reactions mo. Alam mo, Josh, big industry ang radical din. Kasi radical formation and radical reactions can initiate yung glue formation. Radical yun. Yung mga, sa mga, ano nga ito? I think you're familiar with superglue, di ba?
Opo.
Superglue. Do you know that?
Opo.
Ayun, radical formation yun. Another thing is formation ng mga chlorinated compounds for your alkane. Radical formation din yun. So this is an interesting molecule. Okay? So
Opo.
yun nga lang, quite unstable ito at room temp. Okay, okay, so ayan, medyo unstable yata ako. So, okay, so far,
Kaya na po
we're
yung
doing
kaya
good.
na po yung radical.
Oo nga, I'm unstable. So, radical ako ngayon. So far, doing good tayo. Let's proceed with letter C. So, the
Yes.
bond in O2 is shorter than OO bond in compounds that contain ang OO single bond. So, explain this observation. So, this is quite easy. So, double bonds are always shorter than single bonds. What is the reason? That's the observation,
Because
right?
all double bonds are shorter than single bonds.
Mhm. Explain. So, nakalagay dito, explain eh. Observation lang ito. So, I'll give you 1 point here. So, 1 point ka lang dito. Dapat 2 ito eh. So, the question is explain eh. So, you didn't explain why double bonds are always shorter than single bonds. Sige, go
Exactly.
ahead. Explain mo.
If I would explain it, then
Double bonds are shorter.
actually, I don't know why. Because
Oo, correct.
Dati alam mo
Ilang
yun?
beses natin to na brought up eh.
If something
Correct,
is
sir. Last,
more attraction. Kumbaga yung glue po, mas maano po. Syempre, it will go closer. But how I could explain this rigorously is unknown.
Hindi.
no, tama yun. Yung explanation mo. Yeah.
Hmm.
Double
More
bonds will have what?
more attraction po. So, they
Correct.
should,
More. If you have more attraction, what will happen to your bond length?
it should decrease.
Oh, see? Ayun na yung explanation. So, um, double bonds will have higher interaction or higher attraction with one another. So, if they will have higher interaction with one another, they will get closer. That's the reason why double bonds are shorter than single bonds. So, nakuha mo naman yung observation. So, this is correct. This is the always observe. This is the proper observation. Double bonds are always shorter than single bond. But the question here is, explain this observation. So you need to also to provide an explanation for this. So I think last time, ilang beses mo to na-mention. Yan, na-mention mo rin yung glue na yan na analogy mo, right? So if you have a closer interaction, you'll have a shorter bond as well. So
Opo.
yun lang yun. Pwede mong sabihin dito, bond length is inversely proportional to your bond strength. So If you have double bonds, you'll have greater bond strength. If you have greater bond strength, you'll have a shorter bond length. Okay? Yun yung sagot dito ha. Naku, kapag nakamit ka ng mga ganitong tanong, you always remember this explanation. So far, ano ka? For number 1, you have 5/6. Okay? Kasi ito kulang lang to eh. Insufficient. So, partially correct to.
Tsaka
Ayan,
gano'n kunyari,
number...
minsan po ano kunyari yun, ganun yung alam mo, lagay mo pa rin. Kahit hindi ka sure. Kasi parang
Correct.
iniisip niya, baka hindi ito yung complete exam. Ganun po siya eh. Kaya nang bata po siya actually, pag binigyan siya exam tapos may doubt siya, wala siyang sagot. So, you put something,
Ine-empty niya, sir, no? Oo.
o
Kasi baka possibility, correct.
ini-edit
May
niya.
possibility
Kunyari,
magka-partial points ka pa or
as sabi ko sa kanya, don't play the teacher. Don't correct yourself. Just put what you know. Matitis eh. Kung gano'n, gano'n. Di ba po? Kung mali, mali. Kung tama, tama.
mm, correct. Just parang 'di ba parang baka sabihin mo Josh, we're actually contradicting what we're saying na write only as briefly as possible. So tama naman 'yun, yung write briefly as or write your answers as briefly as possible. But if you know something or if you have a partial idea, so you write that as well kasi you might not know na yun pala yung tamang sagot, right?
Abo.
Okay. Okay lang yan. So far, 1 point ka. Tsaka tingnan mo you already know the answer eh. So, hindi mo lang siya na-put into words. Okay, so I think we can have
Now we will have the
the
most
second one. So,
debatable question that has been ever posed.
hindi yan debatable. Nako. So, let's
How is
see.
it? Kasi
Ah,
it is so debatable po. Kasi, ay, wait lang, mali.
go ahead.
So, the thing here po is that, actually, ni-type ko lang po. Ito po dapat yung structure. Why? This is chemically po correct. That in case na, they will finally, actually, it's not chemically correct. Because the
Sige, move.
nitrogen doesn't usually form, like, single bonds. And it's
Mhm.
incredibly weak. But this is technically chemically correct because usually, if nitrogen does form ano naman, single bonds, it's quite strong naman po. So, this will hold on naman. So, technically, this should be the correct answer. Except that, ito naman, wait lang po
Sige, go ahead.
this should be too negative anyway. Let me see. 5 minus 1 minus,
Mhm.
wait lang, 5 minus 2.
Sige, go ahead. Tignan mo,
1,
hindi mo kasi nilagay yung mga valence electrons mo eh. So, hindi mo tuloy ngayon makalculate yung um, formal charge. That's the reason why I'm always telling you, place your valence electrons so that you can easily defend your answer when it comes to structure. Sige ha, to answer this, mag-share ako ngayon ng um, whiteboard after mo mag-drawing. Sige, go ahead. Okay. Oh, Josh, count mo muna. Ilan lahat ng valence mo so far?
2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 plus 6. 7 plus 6 is equal to 13.
O, kulang ka pa ng 3. Kasi azide is 16, right? You know, 16 valence. That's the reason why I'm always telling you, count the valence electrons para mag-drawing mo ng tama yung chemical structure mo. Kasi so far, ang nakikita ko sa iyo ha, ito yung mga, alam mo yan yung mga times ako na times na dahil sa sobrang kabisado ko na yung mga parang nung ako, mga siguro way back college, parang alam ko na yung parang rules and all. Hindi ko na rin binibilang yung valence. Then later on, I realized, ay, mali pala ito. So, you always go back to the valence electrons kasi this will form your bonds. Sila naman talaga yung involved sa bonds eh. Or even though non-bonding electrons sila, sila yung papasok dyan. Okay? Anyway, sige. Ayan muna ha. Yan yung sagot mo. Pag nag-share ba ako, mawawala yung yung board mo? Mukhang hindi naman, no? I mean, this one will be present.
Baka. Dapat
Sige
gawin
nga,
enable po multiple participant sharing po, or something like that.
Save mo para
yeah.
save mo.
Nakaano naman.
Save ko, hindi siya ma-save dito. Ma-save sa computer.
Okay na lang. Para pagka nawala, pwede mo pa i-access. Pwede mo share.
Yeah.
Save mo.
Sige. Itong dalawa lang naman yung so far. Dalawang ito eh. Dalawang, what do you call this? Whiteboard.
Save mo po.
The other one as well. Page 2. Oops. Ginawa mo lang page 4. Go to page 3. Ayun, oops. Ayan, page. Ayan. So, you picture or capture that one as well.
They're all drawings.
Okay na?
Abo.
Very good. Sige. Don't worry. Feeling ko hindi naman mawawala. Ayan, nag-share ako. Nakikita mo na, Josh?
Yeah, wala po.
Okay.
White screen pa po.
Okay. Ayan. Whiteboard na?
Yan na po.
Okay. Try to share lang ulit your whiteboard. I'll stop share.
Alright. Yes!
Diba? Andun pa rin. So, ako ulit mag-share Okay. Share ako ng whiteboard. Ayan. Nako, babalik tayo dun sa mismong lesson natin. Draw azide. The most stable structure for azide. Okay? So, what is our first step for this one? Let's go back to the basics so that you can always recall the importance ng mga bagay-bagay. Very good.
It is too thick.
Calculate first the step 1 will be the valence electrons. So, I told you already, ito yung guide mo. So, how many, what is the group number for nitrogen?
So, 3 times 5.
Very good.
Times 5 plus 5 plus 5. 5 plus 3. 15 plus the negative charge, which is negative 1.
Okay, correct. May negative charge. Means 1 excess valence, right?
Abo. So,
Tama?
16.
Okay, and then decide for the central atom. No choice naman tayo. So, the central atom is nitrogen.
Kasi binigay po kayo ng parang protein, yung dekin po. Binigay po kayo sa inyo po, dekin. What is the central atom?
So, the nitrogen, two nitrogen atoms will be your ligands. Okay? So, ang susunod na step, draw a bond from your central atom papunta sa ligand mo. So, without considering yet the shape. Okay? So, if that is the case, Josh, how many remaining na lang na electrons?
So, 16 minus 4 equals 8, 12. How could I possibly make that mistake? 12 valence electrons.
Okay, 12 valence electrons. So, where will I place the 12 valence electrons first?
1, 2, 3, 4, 5.
Mali. Nako, hindi.
Ito, tapos
Wag
sa
muna.
Sa ligand.
Correct. O, diba? Kaya sinasabi ko sa'yo, you always draw this eh. Kapag medyo nahihirapan ka na, so sa ligand ka ngayon maglalagay.
2, 3, 4, 5, 6.
Okay.
Oh, okay na po yan.
So 2, 4, 6, 2, 4, 6, 8, 12, 14, 16. Okay, so we're seeing 16 na. And then this time, Josh, dito ka ngayon calculate ng formal charge. So shortcut, the formal charge dito sa um, single bond N, yung
Is what?
terminal, that will be group number 5 minus how many bonds?
-1 minus 6.
How many? Okay, very good. So this will be what?
-1.
Negative 1 ba tayo?
-2. Oh, this definitely needs another bond. It is impossible that we will not need another
See?
bond.
I told you. So, because you can easily justify yung mangyayari dun sa mismong structure mo. But later, sige, check muna natin. How about yung central atom mo?
It is not yet okay then. It needs
5
5
minus
minus
2.
2 minus nothing. 3.
So, this
3
will be
plus? Oh,
plus
this
3, right?
This is disgusting. I can just see how disgusting it is. -2, 3, and then -2. Oh, it looks so bad.
Mhm.
Why? It's like it still has the -1 charge, but then all of the big formal charges, they're just too messy.
And another thing, what happens to your overall charge? That's the overall charge for
-1.
this.
-1 pa na po, syempre.
Okay, so negative 1 ba?
Hmm. Hmm. Ah, -2 plus 3, -1 pa rin po.
Negative 2 plus 3 is what?
1 minus 2 equals negative.
Yeah, correct. 1 minus the negative 1. So this is still negative 1. So since this the formal charges are non-zero, so you really need to introduce uh, double bonds here. Tama? So, kay nino ulit manggagaling yung double bonds, Josh?
From the central atom.
Hmm?
No, from the ligand.
No. Sino ba yung
You'll
electron
get
rich?
you'll always get the electrons mo from the ligands. And then transfer
Oo,
them.
kasi sila yung electron rich eh. Okay. So, we'll now have our second structure. So, single muna natin. Sige, sundan lang natin to ha.
Why?
So, double bond na to, right?
Dapat double
Tama?
bond na rin po yung isa kasi -2 rin siya. Joke lang.
Mamaya
Dapat
muna.
negative,
Excited ka kasi. This is still a structure, right? So,
-2
ito,
pa rin po
structure
to.
pa rin naman yan eh. Okay, and then this is? What will happen to your central
Plus
atom this time?
+1.
Positive 1 ba? Are you sure? Sige,
+2.
let's calculate.
+2 po. And then this will
So, this will
be
be 5. Tama ba ako? 5
5
minus 3,
minus 3 minus 0
0.
equals +2.
How about this one? Yung formal charge ni double bond nitrogen. Of course, we know this is negative 2 eh.
5
This is 5.
minus 2 minus 4 equals -1.
Okay, so negative 1. So, what will be, okay, sorry. Sige, go ahead. Ako, ayan. What will be the total?
Negative 1 pa rin po. It will always be
Okay.
-1. As long if you have the right number of valence electrons, it should always be -1.
Correct. So,
And then
this
we
time,
still,
okay.
we still need another
How
double
can we,
bond.
how can we, at least, di ba, what our target is, at least, majority of your atoms will be, the formal charge will be 0. So far, we're not having, or we're not achieving 0, right?
So we
Tama?
need to have another double bond.
Okay, sige. Where will we add another bond?
It's a single bond.
Okay, sige. Ito. Tapos lalagay ko dito. Tama?
So,
Okay,
next.
sige. Ito. So, actually, mga resonance mo ito eh. So,
Then here arises the problem. Ay, dito ka.
Okay,
Here
correct.
arises the big problem.
So, okay, don't worry. We'll solve this problem. What will be the charge here, Josh? -1? Tama? -1. Kasi they are similar, right? From the
Opo.
previous double bond end. Yung terminal.
So
How
there are
about the central atom?
negative one. So this will be plus 1 po. 5
Okay, correct.
minus
5
4
minus 4
minus
minus
0.
0.
So actually,
Okay, good, good,
yung
good.
mga
Ayan.
you might think po, this looks this is unstable kasi meron pa rin po, di ba? So the most stable, in fact po,
Mhm.
should be this. Dapat po this the most stable.
Hindi pa. Ikaw kasi, yan kagad yung inuuna mo eh.
Ano?
Hindi pa. And this is quite wrong. Kasi, tignan mo ha, ang ginawa mo kagad, you assume that another bond will be formed between the either of your terminal, right? You can have
Opo.
another resonance coming from this. Ayan. Huwag mong isasara dito kasi ginawa mong stepwise eh. Parang from here, dito, and then you'll end up with this one. So, from here, you need to move forward using this um, structure. This is wrong.
Actually po, opo.
So, mali yun.
Opo.
Hindi siya sequential eh.
Opo, so
Sige, go ahead.
here comes the question po. So, sinasabi na po, yes, this is a wrong, this is possible, but it's not very plausible kasi, pwede po pa rin po maging zero eh. As much as possible po, make everything zero.
Mhm.
It's possible to make this more zero.
But
But,
remember ha, your atoms are bound with their chemical properties. So tignan mo ha, sige, gagawin ko yung ginawa mo. So you'll have triple bond, right? Tama ba
hindi
ako?
po yan, hindi na po yan. O hindi po may triple band. Kasi pag ito triple band niya po, magmamali na naman.
Hindi, sige, let's try this one. Isa sequential natin. So kasi we don't have any zero formal charge yet, right?
Opo.
Tama ba ako? Okay, we don't have any zero formal charge yet. So, what will happen now? So, ang ginawa ko, ito, nilipat ko siya kunwari dito. So, how many lone pair? This one na lang, right? And
Opo.
then, tama ba ako? Dalawa pa rin to?
Opo.
Okay, let's compute. What will be the formal charge for this one?
That will be 0.
5 minus 3 minus 2. Very good. 0. Ayun, may 0 na tayo, correct?
And then there's
How
another
about this
0.
one? Yung center.
0 lang po yan. 5 minus 3 minus 5 minus 5 minus 0.
Okay, 0. Correct. And then how about this one?
Negative 1.
Correct. So what's the overall charge?
Negative 1 po.
Okay. One major flaw with this is the central atom nitrogen contains 5 bonds. And this is impossible. X, Y.
Why?
I'm asking you. Why? Why na-discuss natin to last time?
Because,
What period is nitrogen? Ayan, babalik ulit ako. Sige. What period is nitrogen?
it is in the second period, which never disobeys often.
Okay. So, very correct. It's very obeying in octet rule. So, nitrogen is period 2. What can you say about the available orbitals for nitrogen?
P.
1s2, 2s2, tsaka 2p, right? Correct?
Opo. P.
Up to 2p6. So, what's the next orbital here?
S.
3s na. And it's quite high. Kasi remember ha, they're separated by energy.
And
So,
then,
the 3s can be...
di ba po ganyan, parang ganito golf ball, tapos ganito.
Yeah,
Like,
correct. Mhm. So, it's quite difficult for your nitrogen to have another bond occupying your 3s because the energy gap is too large. Okay, and another thing, unlike phosphorus, di ba, recall phosphorus? Sir, but phosphorus can have 5 bonds, right?
Opo.
Bakit? What's the major difference between nitrogen and
He
phosphorus?
has literal d orbitals.
Correct.
Like even it
Kasi
is
ito
achieved
ay
the next level.
very good. Kasi may nasa third energy or nasa third period ito eh. This one is in third period. So it means it can extend its available orbital up to the 3D, which is not present to your nitrogen. Kaya yun ang major flaw dito. So this will be hindi naman siya impossible. Baka kasi ayoko magsalita ng tapos baka meron makapag-synthesize ito at very low temperature or at very high temperature, special conditions. But at ordinary conditions, this is impossible talaga. Okay, you won't form this. So, ngayon, scrap ko to ha. I-scrap ko ngayon tong buong to. So, scrap.
Why?
Mali siya eh. Mali siya eh.
No.
Pag mali, scrap mo na kagad. Okay? So, scrap natin.
Life status gone.
But please take note yung explanation na yun, Josh.
Opo.
Nitrogen will always reach up to 8 valence electrons lang or
Opo.
4 bonds maximum.
So,
Eh di,
4
if you
bands
can't
maximum
go
po.
forward from here,
Yun nga po, ito po yung
dito ka,
tamang
punta ka
structure.
dito.
Ha?
Mhm.
Bakit po? Actually, in
Dito ka,
reality,
mag-start ka dito.
this po is the correct structure. Ay, correct.
Hindi pa tayo
Opo.
hindi mo pa sure yan.
Ito po yung
Di ba?
correct
Sige,
structure eh.
ano muna?
Tingnan niyo po sa tingnan niyo po sa Wikipedia. Tsaka tingnan niyo rin po sa lahat po, check all of the
Wikipedia
resources.
yun. Seryoso.
Opo.
Hindi pa tayo tapos. Sige, wait lang. Check
Yung
natin.
mga pan-check.
Oo.
Opo.
You'll be surprised
Siyempre,
kasi.
you can put it here
You'll be
po eh.
surprised with this. Very good. O sige. Sige, continue. Continue doing that. So, another method is instead of adding your double bond here, why not add your double bond here? That is option 2.
Bro, it's like
Okay.
kumbaga po, nag-workout po kayo. And you decide, mag-workout po kayo. May isa na na-form na muscle, so you'll just form it. Diba, parang hindi
Okay.
siya orthodox.
Oh, pero ano let's see. What will be the charge here, Josh?
That's one. And then
Okay,
this one will
this is
be
negative 2, correct? And then,
And then this one is
okay, go ahead.
nothing. This one's nothing. The other one's nothing.
Sige, go ahead. Write mo yung negative 2 doon sa taas. Tapos 0.
The IRL when the negative is right next to the negative.
Sige,
Here.
go ahead.
Why do I put? Why do I
Ikaw magsulat ng mga charges. Ayan, very good. Okay. So, my next question is, eto siya, Josh, the next, unstable na naman ako. Radical na naman ako. Anyway, my next question is, can you hear me, Josh and Sir Jay?
Apa.
Hello po? Naririnig po ako?
Apa,
Narinig po.
Nadidinig niyo po kami.
Ayan. Naririnig ako, Josh?
Opo.
Yes po. Naririnig po. How about me po?
Opo.
Ayun. Okay. So, hala. Ako pa naman yung nag-share. I'm so sad. Ako yung nag-share. Anyway, actually, ano naman siya.
Nawala.
Don't worry. Na-gets mo naman yung yung nuggets mo naman yung doon.
Naka-record naman po. Kung hindi po naka-record or something, wala na po. Diba?
Ang sad. So anyway, we ended up with this one so far. Mabilis naman ako mag-drawing. Yan. Negative 2, 0.
There's a third band po dyan.
Correct? Tama ba tayo? Hindi pa. That will be your original later. Ayan. Siya yung original mo eh. What's our charge here nga pala ulit? So, 5 minus 2 minus 4.
5 minus 2
Wait.
minus
Mali
4
ako.
equals to negative 1.
This is negative 1, right? How about this one? 5
It should
minus 3,
be
positive 2.
3 plus 2.
Okay. So, we derive the other structure by having this one. Ito yung drawing mo kanina. Then N, triple bond N, then one lone pair. Okay? So, of course, we know already this is negative 2, this is plus 1, right? This will be 0. The overall charge will be negative 1. Okay, Josh. Ayan. What can you say about the nitrogen here? Yung mga nitrogen mo.
One nitrogen is extremely weak because it's only bonded by only one. And then one nitrogen is bonded by triple
In
bond.
terms of octet. Octet naman sila lahat, di ba?
All of them are octet naman po except
Correct?
the nitrogen in the middle which decides to have 4 bonds.
How about yung next thing is yung covalency number. So, dun papasok yung covalency number mo eh.
Covalency number, nitrogen
What's your covalency number?
Nitrogen wants 3 bonds po usually. And usually that's
Okay, so it's correct. So far, at least meron kang 3 bonds dito, right? Okay, so may 3 bonds ka naman siya. And then, ito yung next question kasi, Josh eh. My next question is, can this structure perform resonance?
Yes! 2 resonance.
Definitely.
Actually,
So,
resonance.
Kasi pwede siyang pumasok dito, di ba? Right?
Opo.
Ay, mali. Baliktad ako. That is wrong, Josh. Dapat your electrons, paano dapat ang movement ng electrons? Dapat sa electron-rich na ligand.
Opo,
Electron-rich ligand, saan lilipat?
From
Sige, go ahead.
the end with the single bond to the end with the end with the 4. Wait, is that even possible?
Sige, try to do the arrow pushing.
It's impossible
Yung
to
maglagay
go
ka ng mga arrows. So,
here.
encircle mo yung lone pair.
Even possible to that.
Yeah, okay yan. Tama yan. Correct, tama yan.
So do we have
Sige,
5
go ahead.
bonds? So
Hindi
see.
pa. Sige. Nope. Ibig sabihin, the other bond will be given up on the other side. So, ibigay mo yung lone pair dun sa kabila.
Okay.
Yan. What will happen?
Technically, I can still add
sulat
another
mo yung
one and then this one will go here. But it's just symmetrical, so it doesn't matter anyway. So
Ay, hindi pa. Wag mong burahin yung mga lone pairs. That's the reason why you're drawing resonance structures. So, sige, go ahead.
Lone pair. Hindi po ako master ng board.
Sige. Isang movement ka muna. Draw the structure now. Sige, ikaw mag-drawing. Okay, good.
Your battery is running low. Oh no. See? I told you to put it here on standby. Dun, 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 dun.
Ayan, tama yan yung ginawa mo. Etong lone pair, mag-move yan dito. That's correct. Okay?
Toad din. Oh, grabe. Liwanag po ng mukha ko po. Sakit. Oh. The light is too bright.
Sinusubukan po namin to, bagong gadget po to eh. Yung dati po, pagka may engineer, ayaw na talaga po, nagluloko na talaga eh. Pero kahapon sa kanina, nagluloko siya kanina. yung audio.
Di ba? Ito yung proposed
Kasi po
structure
yung
mo.
ano eh, it's because of the Zoom. The Zoom wants money.
Di ba yan yung proposed structure mo, Josh? Kanina?
Ah, so actually po, this should be the other way around.
Oh, yes.
This should
Paano
be,
lang siya?
this
Part,
should be,
part
this
siya
should
ng
be
ano.
more stable.
Mhm.
And then this one is the least stable. Less stable. But then it is also stable. I actually do not get how this could be stable. Just look at the formal charges po. How could this possibly be stable?
Di pa. Sige, answer pa natin. Oh, next. Can you have another resonance structure?
No. Because
Hmm.
if I make it ganito naman po, like this, then
Mhm.
this is symmetrical because all of them are nitrogen atoms anyway. I just flipped it.
No. They are not symmetrical, Josh. These are
How?
different nitrogen atoms. This nitrogen is
Can you
single
tell
bond,
what's
right?
the difference? Can you tell what's the difference po between one nitrogen atom and the other?
Eh, paano kung isotopic ito? Do you think it will be symmetrical?
Oh!
Hmm. 'Di ba? That's the behind isotopic labeling. Hmm. Oh,
Ay!
let's say because I'm bad. Let's say this is nitrogen 'di ba we have nitrogen 14, right? So let's say these are all nitrogen 14 except for the left one, it's nitrogen 17. Oh, edi hindi kagad sila symmetrical. I'm exposing you now to
I
the
just died.
realities of atoms.
I
Sige,
just died.
continue.
Why?
Don't worry, at least naisip mo at least alam mo na nasa susunod na okay, we can't easily assume that atoms will be equal because you have isotopes. Even though they exist in small amounts, right?
Kung ako po yung teachers na narinig ko po isotopic compound. Bro,
Anyway, oy, may mali ka pa kasi dito eh. You didn't draw the resonance structure. Yan.
what?
Then you'll have this negative one. I mean the resonance arrow. Okay? Babalik tayo sa basic,
So,
Josh.
wait lang po.
Sige,
So
go ahead.
it's not just one resonance structure. So it's like, this is extremely weird. I have not used this. This is the worst possible resonance structure. Like this
Mm-hmm.
po. Dalawa?
Yeah,
Kasi,
that
ito
can be
din po.
possible kung resonance hybrid ito. Okay?
Opo.
Kung may resonance hybrid ka. So, ngayon, ang tanong dito, Josh, is um, let's ask ourselves muna, with these given structures, do you think among the three, you can have the most stable structure? Tama ba? Yun muna yung tanong mo sa sarili mo.
Mm,
Among the three, hindi pa natin tinatanong Josh ha. My only question is, with these three given resonance structures, because these are all resonance with each other do you think one of them will be the most stable structure? Yes or no? Yun muna yung tanong.
one of them is the most stable structure.
Mm-mm.
And
Hindi
this is
pa
this.
natin i-identify kung sino yung pinaka-stable.
There must be a more stable one because out of them, it is clear to see which one was the more stable.
Exactly. So, ang sagot mo, yes. Why?
I don't know. It's just intuition because you can see po.
Sige, go
I'm
ahead.
just observing kasi kumbaga
Correct,
po,
yeah.
nakikita po kayong tao, maskulado po, pero isa parang liit, tapos yung isa parang
Correct.
parang ganun pa yung sila.
Yun yung nakikita mong parang analogy for the other two
Parang,
resonance
parang
structures
mukhang anomaly.
Mm-mm. Correct. So, that's a good observation. But, recall, yan, may recall tayo. Recall,
Why? Recall only.
if you have the number of resonance structures that you can draw, represent what? Naalala mo
The
yun?
represent
Nako. If you
they
have,
represent also stable
no, sige,
structures.
the number, I'm asking for the number of resonance structures They will represent what?
The number of stable structures. Whatever.
If you have more resonance structures, what can you say about the structure?
Then it is not given. The structure can change.
Yeah, the structure can interchange with one another, right? Kasi nga, resonance eh.
Abo.
Okay, or, naku, nakalimutan mo na yata to. Mukhang,
Or
the
the
higher
thing
the
of
resonance structures, the higher the stability.
what? How? If the things
Oh,
if something po will have if something po will have 5 resonance structures, like in theory po ganito, then is it more stable because it looks doesn't look stable?
hmm, okay. So that's your, diba classical example natin si benzene?
Ah, benzene. Yay. Abo.
Hmm. Because you can draw at least 2 structures for benzene. The higher the resonance structures, it means your drawn resonance structures, one of them, or you can combine them, will be your most stable structure. Tama ba ako? Ako
Abo.
yan yung inaral natin. Okay. So if that is the case, the answer is yes. Tama ka naman because we can actually pinpoint which one will give us the more stable structure. Okay? And actually, we drawn 3 or we actually provided 3 resonance structures, right? So if that is the case, stable na itong na-drawing natin na na resonance structures. Ito ngayon yung next question mo. So this is a good
Why?
Can this one exist, the resonance hybrid? The
Yes.
problem,
Well, I can see po in this example po there's a -1 formal charge and there's a +1 formal charge. It will want to cancel out that, but then it will realize like in after maybe 5 minutes or something, it will realize, hey look, I made this thing unbalanced. Ay,
mhm,
unbalanced. So I will just revert
mhm,
back to the normal and then I'll just go here and then the electrons basically, if you think about that po, kasi kung magaganito po yan, di ba? So, 1, 2, 3. So, maggaganon. Tapos ang
correct.
matatanggal. Kung
Ayan,
magiging
na-imagine ko
ganyan,
siya
tapos ang magiging ganyan. So, basically, parang siyang sliding na ano po. Parang isipin niyo po, sliding yung
Exactly.
bag.
Oo. Ganun siya. Ganun yung nangyayari. Mabilis siyang lumilipat-lipat. But if you will notice here, we'll have a more preferred structure. Ito ngayon yun. Yan.
Opo.
This will be your more preferred structure. Let's analyze Sir, bakit ito po yung more preferred mo compared to this one? Kasi ito naman ay 0. Meron ka ding 0 dito. Pero all of them will have, all of this will have a -1 charge, right? So, may resonance hybrid ka ba? Yes, may resonance hybrid ka. But your resonance hybrid will not be the most representative structure because your structure will prefer to have this one. So remember, Joshua, you're creating resonance hybrid structure if and only if you have equal contributions for resonance structures. Equal ba yung contributions nila? Of course, hindi. Kasi we're pinpointing here na this one is more stable, right? So, mas stable ito So, if that is the case, it means this is a more contributing structure. More contributing structure compared to the other two. So parang most of the time, Josh, your A side will be present like this in reality. Okay?
Opo.
Ngayon, ano natin dito, Josh ha? Ano nga ito? Why are we choosing this N double bond, N double bond? Okay? Because if you will notice, what can you say about the bonds here or the bond length?
The band lengths
Yan.
are assuming to be equal. Are assumed to be equal. Opo.
Again, hindi. For the triple bond and single bond,
They're totally different. Yung triple band is very small and then the single band is much bigger.
much bigger. Triple bond?
Triple band, much smaller pala, sorry po. Nag-glitch pa yung brain ko.
Correct.
So, it is much smaller than the single band.
Okay.
So, it's uneven.
Very good. So, shorter dapat siya. But, ito kasi ngayon yung susunod na consequence. By experiment, Josh, the azide bonds are equal. Sige, type mo o kaya search natin na azide bond length.
Not always po. Kasi,
So, the
ito po
azide
yung,
bond length.
ito po yung inano ko po. This is my contradiction. If we replace
Mm-hmm.
one of the electrons in a carbon atom, in an oxygen atom by a muon, then the muon will stick so close to the nucleus that it will act like nitrogen. So
What will happen?
you can therefore consider it po to be a nitrogen atom. It will supposedly behave like a nitrogen atom. So now ngayon po, you will bond it in such a way sa acid po,
Wait, wait,
diba?
wait. Mag-a-add ka ng oxygen dito sa azide?
Opo, but then the oxygen has one of the electrons replaced by a muon, so it will act like a nitrogen because the muon will go very close to the nucleus.
No. Wait lang ha. Later natin yung sagutin. Gusto ko yung tanong mo din magkakaroon ng oxygen atom dito. But with this one muna, balik tayo dito. How about dito sa more stable structure? What can you say about the bond length?
The bandas are very equal. But not always
Correct.
na po yung sasabihin ko po na example. When the bundles of nitrogen are not equal. Anyway, so
Why?
usually for most of the time na po, most of them are equal.
Mm-hmm. But hindi. I'm speaking about or I'm asking about the structure na ito lang. Specific.
Opo.
So ano to? What can you say about the bond length?
Most of the time po equal.
Ngayon, equal to. Alam mo kung bakit ito yung more stable? Kasi this one represents your experimental data. Because according to experiments,
I don't know
the
po
azide bonds are
data.
equal.
If I don't know the experimental data po, how could I possibly judge which one is the more stable one? How could I
If you don't
possibly
know.
judge if I don't know the experimental data po?
Correct, tama yun. Another good observation yun. So the next one will be, you try to analyze the, ano ba to? That's a good question Kasi kung ako lang din, parang mas okay pa tong mga dalawa, right? Kasi may zero ka dito You
Opo.
achieve a zero here And then for this one, you also have a stable structure here. But if you will notice, the resonance, yung parang, alam mo yun yung sinabi mo kanina, yung meron kang unbalanced na muscle with this one.
Opo.
Okay? And then both of them will lead to this structure. Parang to make everything balanced or to make everything stable, it's quite difficult to hold on to triple bonds. Okay? Kasi shorter masyado yung mga bonds na to So, for nitrogen, so recall, for nitrogen,
I don't think it's hard to lose. It's hard to keep. But I think it's harder to keep the single bond because the single bond is much weaker po. It should take actually a little less energy. It should take less energy for it to
yeah,
be lost.
little less energy for bond breaking, not for resonance forming. Magkaiba kasi sila Right?
Opo.
Another thing, Joshua, ano yung mga charge mo for your nitrogens on your terminal? You know, negative 2, tsaka negative 2, di ba? So, you have a high negative charge on your nitrogen. Pero, on your middle structure, yung double bond, what happened to your negative structures or negative charges?
They got they got removed. Kumbaga, they're still
Or
there po, but
they're
essentially, they got neutralized technically. Kasi nasa opposite
correct,
sides.
or they're on nasa side sila. They're actually distributed equally.
Opo, sa CO2 po, ganun po, diba? It's actually polar,
Yes,
but
correct.
the poles are up in
Mm-hmm.
opposite directions.
Mm-hmm. Correct. So, which is also another good explanation why you will have this more stable. Kaya nga yun yung sagot mo naman na ito, it's actually correct. Pero ang problem mo dito, Josh, hindi kasi siya lang yung pinakatamang sagot eh. Ang tanong kasi, draw the other resonance structures. So, if I will judge your answer, yeah, you got it right. Yung the more contributing structure will be your structure. Ito yon. Pero aside from that, you need to have these structures as well. Okay,
Opo.
so clear na tayo dito. Bakit ito yung pinakasagot natin? Tama
Opo.
ka dun ha. Tama, ayan. Pero ang problem mo, hindi mo nakuha tong mga to. Yung dalawa. So, yung tingin mong akala mo uneven na, ano nga ito, uneven muscles. Natawa ako sa analogy, uneven muscles. Anyway, this is a challenging ito, tong azide. At alam mo, Josh, kung bakit ko na sabi ito. Kasi, Josh, kapag nag-reaction sila, ito, this is very important, Josh, ha? If this will take a reaction, Josh, or if this one will have a reaction, alam mo, Josh, kung ano yung mangyayari. This will automatically form a triple bond. Okay? So, yan. O kaya, nagkakaroon ng ganito yan. Nagko-close ring yan minsan eh. Nagaganito siya, Josh, oh. Yan. Tapos, magbaband yan together. O kaya yan. Yan. Pwede siyang mapunta dito. Carbon mo, and then nitrogen. Carbon ulit, sorry. Carbon. Tapos magko-close ring yan. Okay? This will be your azide formation. Wala yan na. Yan. So, wala rin ito. Yan. Mga azide yan eh. Pang-close kasi itong azide eh. Pang-buo siya ng ring. Yan, no? So, if you will notice, nitrogen, double bond, nitrogen, single bond, nitrogen, double bond. So, yung isang double bond dito, yun yung pinangbubuo with your carbon. At saka may mga lone pairs yan sila. Okay, so a really interesting molecule, azide. Ito, pinangre-react yan, yung azide. Ayan, nakagamit na ako niyan. Ano to eh? Unstable yan, Josh, kapag in-expose mo lang ng sa hangin. Kaya dapat lagi din siyang naka-close o kaya you'll just open that one if you need the reaction. Nakagamit na ako niyan.
Isip po is an ion. So,
Powder to. Naka-salt form siya. Naka-salt form. Yan. Usually, you can buy azide in sodium azide. Naka-salt form. Ayan, powder yan eh. Okay? So, syempre, is it soluble in water? Yes, kasi salt ito eh. Tsaka ano yung kasama ni azide? Tingnan mo.
Opo.
What is together with azide?
Sodium. Wait na po.
Sodium.
Ito po, sodium azide po, diba ginagamit po yan sa mga airbag?
Yes, oo, correct. Tama ka doon. Sodium azide yun. Nitrogen gas yung nabubuo.
Opo.
Okay, so I think, share mo ulit yung ano mo. Then, scoreran ko siya. Stop sharing muna ha. There. Share mo ulit yung screen mo. Tapos, scoreran natin.
Ayoko po.
Sige, don't worry. Wag mo na, ipakita mo na. Nakita ko naman yung sagot mo kanina eh. So, yan. Ilang points ba ito?
Umalis. Ayun. There. Okay, so...
Lipat mo muna, page 1. Go to page 1. Okay. So, for number 2, okay, you have 4 points. So, nako, ito yung nakuha mo. Okay naman, at least. So, at least 2 over 4 ka. Okay? So, 2 over 4. 5 over 6. So, Yeah, this possibly can exist. What is your main problem here, Josh? For the triangular azide or
Kasi,
cyclo
yung
um
cycloazide po
propane
kasi
na
alam ko,
azide?
yung, ano nga po, diba yung ozone? I
Hmm.
think it has the same problem.
Mm-hmm. Oh, yes, correct. Ano yung
Yung
problem?
mga angles po.
Very good, angle strain.
Opo, may mga, ayun po, angle strain.
High angle strain. Very high angle strain. What's the ideal for yung N double bond N?
What?
Anong ideal bond dapat?
Di ko alam po.
Oh, 120, di ba?
Ano,
Oh,
120?
kasi 120.
Opo.
N double bond N eh, right? Parang
Opo.
ganito siya, oh, di ba? Ayan, double bond N, tapos ito yung isa mo, tapos ito yung lone pair mo, right? Ano?
Opo. Opo.
Correct? Nakikita mo siya better? This is
Kita po.
120. So, ito, ano lang to?
One, huh?
Uy,
60.
triangle. 60 lang. Okay, correct. So, you have a high angle strain here. Correct. Okay, so, yeah. Let's move on with the next problem natin. And check natin yung sagot mo sa 3.
Saan yung... Nawala na po yung
Next.
ano eh. Parang nag-glitch po ng Windows. So, nakalabas pa rin po yung bar. Anyway.
Hindi, pero nakikita ko yan, yung sagot mo. Tama naman. I can see your screen. Hindi ko sinasabing tama yung sagot mo agad, ha?
Oh! May
Draw
sinabi
the
po.
molecular orbital diagram of N2. Does it conform on what is predicted by the valence band theory and explain its magnetic property? Okay. So, let's start. Ang kulang mo lang dito, by the way, Joshua, the next time you will draw, pero considered ko naman, 1s. Kasi 'di ba ang nitrogen is 1s2, 2s2, 2p3. Correct?
Opo. Pero yung one is po yun, parang siyang degenerate kumaga.
Yeah.
Not needed
Ano
anymore.
naman ito? Parang the same lang. Kamukha lang siya ni 2s. Okay,
Opo.
ginawa mo lang siyang 1s. Correct. So, what's important here is for the 2p. So, correct, you have tatlong p electrons and then you mix that. So, definitely, you'll have your N2. And N2 will have, anong tawag natin dito? Yung mas mababa pa yung pi 2p kaysa sa sigma 2p.
I forgot
Correct.
mas called. But
Oh.
I just applied it po kasi I was assuming nitrogen was the same as yung mga other po na kasi oxygen.
Ay, hybrid orbital tuloy. What's the term for this one? Yung mas bumaba yung sigma ay pi 2p compared to your sigma. That's correct, ha? That will be your, ang term natin ay orbital o M.
Orbital moling, orbital, orbit, what? Orbital,
What happens to your sigma 2p and pi 2p? Para silang na-rearrange or
nag, nagmo, what? Nagmameni momu, na, this is hard to
uh,
say.
ing to.
Mooning,
Isang
mining,
letter na lang.
mining,
Hindi.
mining,
Hindi.
mining. Wait lang po.
Hindi.
My, my,
Nako po. Uh,
mixing, mixing! Ah!
correct. Orbital mixing yan, right? So, due to orbital mixing, you'll have lower pi 2p, lower pi 2p in energy or compared to your than sigma 2p. That's correct. So, if that is the case, so combine yung 6 na electrons. So, you'll have 2, 4, 6. So, what's your bond order here? So, bond order will be, ano nga ulit formula ng bond order, Josh?
I forgot. I forgot.
Mhm. Count
Ah,
the
count the number of field
bonding
orbital,
molecular orbital. Correct.
bonding
Bonding
molecular
molecular
orbital
orbital.
sa last sa home.
Minus,
Ay, bonding molecular minus non-bonding.
okay, anti-bonding.
Ay,
Anti-bonding molecular orbital.
so
Then,
antibonding
times
po,
mo sa,
they are molecular bonds po, but then they subtract from the, di po sila, they are technically molecular orbitals, but then they subtract from the number of molecular bonds.
mm, so 1/2 bonding molecular
So
orbital
basically
minus
po,
anti-bonding
so what happens
molecular
po if,
orbital.
is it even possible to get more anti-bonding molecular orbitals than bonding molecular
Ah,
orbitals?
hindi. Hindi siya. Kasi equal ang bonding mo and anti-bonding eh. So, lagi siyang equal eh. So, you can only have 0 na difference.
Opo.
Right? Kasi you'll have equal number of bonding molecular orbitals and anti-bonding molecular orbitals. So, equal yan sila. So, if that is the case, Josh, ano na ngayon ang mangyayari? So, you'll have 1/2. So, ilan? Tingin ka na lang sa 2p. Kasi cancel naman yan sa 1s and 2s eh.
3,
So, 6, correct?
6 minus none.
Okay, correct. So, wala naman nag-occupy ng sigma star mo eh. Or tsaka pi star. This will be 6 minus 0, 6 over 2. Bond order is 3. Okay, correct ito. So, 1 point ito. Tapos, I'll give you 2 points here. That's correct. So, bond order is 3. So, BBT also says the same thing. So, paano tong says the same thing? Ibig sabihin, they agree together, right?
Opo.
Why? Because,
Because sa BBT po, di ba ano po, yung merging naman po of merging naman po of, of, ala, ano yung tawag po doon, of
atomic orbitals.
atomic orbitals.
Of
So,
overlapping. Overlapping ito, not merging.
opo, overlapping.
Right? What can you say about the nitrogen molecule? Pag BBT. Ilang bonds? According to BBT. Ha?
3 po.
Correct. Diba ayan yung sa BBT? Right?
Opo. So, it obvious
They,
naman.
correct. They will have the same thing. So, correct din ito. So, let's say you have 1 point here. Then, finally, what can you say about magnetism?
Nitrogen is totally not paramagnetic.
Okay.
It's diamagnetic kasi ano po, for all materials, as long as they are not paramagnetic, ferromagnetic or
Mhm.
ferromagnetic, they are always
Mhm.
diamagnetic. Even humans po are diamagnetic. You can
Mhm.
technically, may ginawa na po sila, diba yung levitate na po yung frog using
Oo.
a lot of methods.
Mhm. Na-levitate ba nila yung frogs?
Opo, yung mga maliit na frog, yung maliit pa, kasi yung mga 1 millimeter long. Meron po sila maliit.
Grabe, kawawang frog na expose sa um, magnetism. Anyway, that's correct. So, if we don't see any unpaired electrons here, so therefore, nitrogen gas is diamagnetic. So, let's say 2 dito. So far, ilang
Nakalimutan ko po yung diamagnetic eh. Munti ko na po sabihin na ano eh. Na not paramagnetic.
mm. So, diamagnetic yan. So, 6 over 6 ang score mo dito. So, so far, i-total lang natin na 6 ito. Hindi, sige. 6 yan. Mamaya na. Sige. Siguro we'll end our session with last problem. Kaya pa ba, Josh?
Ano po? Bakit? Siyempre po kaya man. Actually,
Okay.
kung makakaano po sana kasi makaka-break even po ako sa mga number of points po sa mga ano eh, mga structure. So, alam ko na I am 100% sure po I will be able to get all of the
Sige.
structures correct.
Ah, sige,
Anyway.
continue. You go now to number 4. Number 4 is Bourne-Haber cycle. I think your favorite mo ito eh. So, Use the Bourne-Haber cycle to calculate the lattice energy of potassium chloride given the following data. So, meron ka bang copy dyan?
No.
Wala kang copy? Ha?
Meron po akong copy po ng 4. Yung Born
Okay,
Neighbor
sige. Go
Cycle
ahead.
po.
Sige, ano ka? Move ka ng next page.
Move
Sige,
next.
next page mo na lang.
The next page, the move the next page. The next page, the move. I cannot move that to the next page because it's not there.
Sige. Ayan, sige. Go ahead. This will be our last problem for tonight. The Bourne-Haber cycle for potassium chloride.
RIP.
Okay. Just tell me if you're done ha, para at least we
So is
can
it going
check.
to be a problem?
Why? Don't worry.
Is it possible?
Parang nakailang Bourne-Haber tayo nung last time.
Okay, I will try to remember what the Born Neighbor Cycle looks like.
Sige, go ahead. Born-Haber cycle is your lattice energy. The definition of your lattice energy.
KCL ko na. Okay, KCLS.
Yep, KCl.
So we have the bottom layer. It is equal to I do not know what this is. This KCl solid. Oh, so ugly. Oh, hurts my eyes. KCl solid. And then this will be. As I remember po there. Dito ba? This should be fairly easy.
Ba, naaalala pa. Yan, sige, go ahead.
Let's hope I remember what are the names of this. I don't know the names actually. I've forgotten all of them. So I am trying to recall one half CL2 because what am I doing? I do not know. Plus wait a minute. Was it supposed to be? I forgot the names. Anyway, I don't know what that is. I think that's vaporization. To just be sure. And then it should be BDE, I think. Plus what's BD? Which BDF what? This is not BDA yet. This is ionization. First IE. And then this will be BDE. Oh, what's this? Oh, I forgot something. Oh, okay. I do not know. Hmm.
Okay, so you're doing good. May dog ba kayo, Joshua?
Ha? Wala po.
May dogs din. Ah, wala kayong dogs. Okay. Akala ko may dog kayo. Minsan may naririnig akong tumatawal-tawal.
Oo po. Nandun po sa labas.
Ah, ako meron eh. Charan! May Tanjiro. Ay, ewan ko lang. You're watching anime ba?
Togo. Yay! Ay, yung ano po sa Demon Slayer? Hindi ko lang.
Wow! Alam mo yung Demon Slayer? Yes! Siya si
Oh.
Tanjiro.
Ah,
Tanjiro-kun.
hello. Cute. Yay!
Say hi
Aba,
daw. Say hi. Say hi.
hello. Ay,
Sige, go
ano
ahead.
na Electron
O,
Affinity.
hindi pa
Yes, I
tapos.
remember. It is Electron Affinity.
Correct. Tama.
And then, this will be the last. Ha! Genius. Now all I have to do is to write. This is delta H formation. This is delta H vap. This is RAP. Oh no! No! First IE. Ha! I remember. This
And you
is...
don't have, wala ka namang first IE, wala ka namang second IE, right? Because you don't have a plus 2.
Opo. So, it is kind of unnecessary. And then this
So,
is...
mhm.
This is something. This is electron affinity. I almost forgot it again. Okay, EE.
How about the yellow one?
LE. Ha! I
Very
cannot
good.
possibly forget this. If I forget this po, then it means hindi na po ma-solve.
And then this is, again, this is also an illustration of what law?
Jesus law.
Very
Oh
good.
no,
Correct. Tama.
thermodynamics flashbacks.
Yeah, this is also thermodynamics. Eh. We just applied it on chemical bonding.
Now I have to apply. This is supposed to be lattice energy. Uh-huh. So this should be equal to this one. Divisible ba? One plus two plus three plus four. Ah, okay. R.I.P. I forgot
Okay,
everything.
sige, continue. O, lagay mo na yung mga values.
Something is telling me that this is a
What?
this is a negative. Something is telling me this is a negative, and it probably is. This is a
We'll
minus.
see, we'll see.
Sussy! I do not know what I'm doing. What am I doing? Where's Each swap. Oh, okay. 79. Oh, tang, 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 tang. What I have to read this all over again, I think. I'm missing something. So,
Yeah. So don't worry. You just get wait.
L-E,
You write first the values beside your symbols. Like kunwari delta H not F is what is the value. Delta H VAP what is the value. First
aba.
IE what is the value. Go
I
ahead.
think I should put this here because it's a gabble.
Sige, go ahead. Sige, sige. Yan. Correct yan. Para at least you'll have a lot of space sa baba.
Finally. Tang, tang, tang. I don't know what I'm doing to doing. Uh-huh. Dun, dun, dun. I am doing everything that I possibly know. I- Okay, LE equals LE
Okay, you're doing good.
LE equals 435.7 minus minus missing something's miss. Yes. Dun, dun, dun. Now I need the calculator.
Okay, and
Wow,
now the end is
it is
there.
very it is very big.
Hmm. Negative?
I don't know.
Okay. Ayan na ba yung final answer mo?
Opo. Kasi,
Hmm.
dati if is ano eh, negative. Tapos negative, 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 minus, 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 minus.
Nako, ilagay mo yung mga values. Sige. You place the values beside your kunwari, ayan, BDE, what is the value? Oh, why did you erase
Diba
that
po,
one?
I will just put them where they belong.
Mm-hmm.
Yes.
Okay, delta H not formation. Josh, why are you having minus? Minus, minus, minus. Why not add? Because this will be ano, di ba?
It will be the same thing anyway po eh. Kasi matatanggal naman yung ano, yung parenthesis. What's this? BDE.
Okay, continue. So, di ba parang, wait, let me do annotation. This one, parang LE is equal to the sum of this one, then minus EA, right?
Opo.
Okay, anyway, you can do whatever you want.
I don't know.
Sige, okay, try mo. What will happen now?
I have a feeling this is wrong because algebraically it doesn't seem sound.
Sige. Sige, go. You try to add them up.
All of them naman po are pretty.
Negative
I think they will add up
435.7
and it will become
2 plus
positive.
418.7 plus
Oh,
224.8.
huzzah! It is it is an integer. What? Oh my gosh, it's an integer.
Why? What's your answer?
Looks kinda sus though. Very small.
Wait, let us, Aha. Ano ba yung mga binigay? Let's double check. So, delta H sublimation, 79.2. Uy, wala kang delta H sublimation, Josh.
HVAC po yan.
Okay. Sublimation, 79.2. Yeah. Solid to gas. Kasi hindi naman siya vaporization. Vaporization is liquid to gas, di ba? Delta H sub yan. Ikaw talaga, ha? Change the value. Delta H sub. Because when you say vaporization, it's liquid to gas. So, pero if it's solid to gas, that will be sublimation. So, I'll just write the values here. Para hindi lang ako malito. 79.2. That's correct. kJ per mole. And then the first IE is 418.7. And then BDE is 242.8. Okay, 242.8. And then EA is negative 348. Then delta H dot formation is negative 435.7. Josh, what can you say about the EA? Bakit kulay blue siya?
Yung ano po, EA?
Mm-mm.
It is negative.
So, di dapat red siya, right? Red arrow.
Uh-huh.
Yeah.
Tung, 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 tung.
Let's, I'll be trying something. Equal 2.8 plus. Negative 435.7. Yay. Here you go. So let's analyze now, ah. So delta H naught formation, let's try here. So formation is 1 mole, correct? 1 KCl. So K solid here. Ayun. We're missing something pala. Okay. So
What's missing?
how do I do this? Your Cl2.
What is
Ito
CL2
oh.
po?
Cl2 KCl. Bakit F to, Josh?
I realized. What F?
Ito, this bond dissociation energy. So, di ba,
Ito
it's
po
1
na.
half Cl2. So, should we
Yeah.
multiply this one by 1 half as well?
Tung, 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 tung. Eh,
Correct,
di
di ba?
sila. Kasi kakala ko po, wala naman ng multiply kasi hindi naman maraming atoms. Dapat po lagay na, ay, ano yan? Anyway, naka-line po yun pala.
Mhm.
Mhm. Mhm. Mhm. Mhm. Which is, weirdly, it managed to be perfectly an even number. Which will make not much, nothing much will happen.
Yeah, let's see, let's see.
Equals negative 164.4 kg per mole. What's this? Hello po.
Hello, hello.
Ayun na
Yan.
po.
Okay, so, wait, I'm searching for, hindi naman searching, verifying yung mismong answer ko. But, kasi I have an idea for the answer eh. Okay. So if we will see here, or if we will notice, okay, let's now discuss this one. So what must be the formula of your lattice energy? So your lattice energy must be the combination of this, correct? Tama ito, di ba? You need to
Opo.
combine this one and then subtract your EA, correct?
Opo.
Mhm. Okay, tama tayo. So, If that is the case, so you need to, parang dapat ang value mo, this must be combined eh. So, your delta H naught formation should not be negative. So, instead, it should be negated. So, dapat negative delta H naught formation ito.
Oh,
Kasi
I am
if you will negate, yan. So, if you will negate that, you will not be considering the value of your delta H naught or enthalpy. O, sige. You calculate now your value.
when it is positive.
Magiging ganyan yan eh.
Sus.
Sige, go. Go ahead. Dapat negative delta H naught formation plus delta H sub plus first IE plus BDE minus EA.
It's an integer. This is one of the rarest things in all of science to get an integer as an answer.
What's your answer now?
Exactly 707.
Exactly. That's the answer. 707. Correct.
Nice.
Nice. Kaso lang, careful ka with this one So please take note Josh. Listen. Please take
Opo.
note that this one should add up by value. Okay, and another thing, this one, be careful with this, times 1/2 ito There's a factor here. Okay, and then, ano pa ba? Yeah, I think that's it. So, we're good with this one. So, next meeting we'll have, sa Saturday, we'll have the BDE na. Okay, then you recall yung BDE.
Yung mga structures. Which I am
And the structures.
which I am sure po is worth 10 out of 10. Unless hindi po
Wow! Yeah. Madali lang naman yung mga structures na binigay ko eh. If ever, let's say, may maisip akong structure on Saturday, we can have another, you can propose a structure there. Okay, so, isip pa ako ng mga structure. Kahit isa lang or dalawa. Just to reinforce what you know about chemical bonding. Okay? I think we're good for tonight. So, ayan, enjoy the rest of the night, Joshua, and eat well. So, I'll see you on...
Eat well po, naubos na po lahat ng pagkain.
Ako nga kakain pa lang ulit. Though nagmerienda ako ng cake kanina eh. So, yun lang yung merienda. Okay, enjoy the rest of the night. Say regards lang to to your dad. May magpakita ka. Nasaan ka na? Wala ka.
I am gone. I do not know where I am.
You turned off your camera a while ago.
How do I turn on my camera? I am not. Hello?
Hello.
I cannot turn on my camera. Turn on start video. There. Diba?
Bye, Josh.
Bye po.
See you on Saturday, Saturday yung next natin. Salamat.
Thank you po.
Yeah. Good night,
Thank you po. Good night po. Bye-bye po.